everyone. So today we're going to do lesson 2.5 on transformations of functions. We're going to start out with a little investigation using the square root function, and I've made a GeoGebra file for you guys to open, and it already has the three sliders A, H, and K in it that we're going to take a look at, see how they affect this graph. So the first thing that I want to go over is just the parent function, y equals the square root of x. When you open up the GeoGebra file, it is the graph that you see. I'm going to do a little sketch of it right here. So that is the square root function graph that you guys should see. Its domain, all the x values that it hits. You can see here it starts at 0 and it hits all the x values moving out to infinity. So 0 to infinity, or you might say x is greater than or equal to 0. The y values that get hit start at 0, and it's going to continually creep up higher and higher and higher as x approaches infinity. So therefore the range is also 0 to infinity, or y is greater than or equal to 0. So the three sliders that you guys have built in, you've got a slider for A, H, and K. And what I want you to do is move the A, H, and K sliders. And what I want you to do on this next slide as you go is take a look specifically at these values for each slider and tell me what happens to the graph. Like, how does this parent function up here change as A, H, and K change? So go ahead and take a minute to investigate, and then we'll outline and see what happens here in just a minute. Okay, so now that you've had time to investigate the A, H, and K sliders for the square root function, what we want to do is we want to generalize what happens to all functions whenever they have these different values placed in the right places. So the first one, when I was looking at the square root function, when I was looking at this A value out front, when the absolute value of A was greater than 1, so I don't care about its positive or negativeness, just the value itself, you should have seen that we had this vertical stretch occur. So you saw that it went higher and higher, or even lower and lower. It kind of affected, I hate to use the word width, but that's kind of what it did. So you kind of saw it move in this direction. So we say that when the A value is greater than 1, you've got a vertical stretch by a factor of whatever A value is. And what's happening here is you can see the y values are getting multiplied by that A value. So for instance, here my A value is 1 on the parent function. Whatever A is, we're multiplying by that A value, and that's where we get that new y value. If the absolute A is in between 0 and 1, we call that a vertical shrink or compression. Compression. And it's still by a factor of A. If the A value is negative, you guys probably saw it flipped upside down like this. So you still have the vertical shrink or stretch going on, and that's what's causing it to be, narrow or wide, but now it's opening upside down, and we're going to talk about why that happens when you have a negative out front in the next investigation. Now what I want to talk about is the H. So this H right here on the inside, what you should have noticed is when you saw H was greater than 0, you should have seen that the shape of the function didn't change, but it shifted to the right. So this is, oops, hold on one second. Did not mean to do, I don't even know what I just did. There we go. Hold on one second. Okay, that should be better now. Sorry about that. So you should have seen a horizontal shift to the right H units. And that's when H is greater than 0. But remember, because of this negative inside here that's built in, let me erase, well, I guess I can't erase that. Never mind. So it's a negative right here. So that you would see x minus some value, that's a shift to the right. Whenever you had an h less than 0, well then you had inside there an x minus a negative number, so you saw an x plus that value of h. You saw that it moved to the left, but it still had the same shape. So this is a horizontal shift to the left, h units. And then finally, the last one, the k value out here in the back. Hopefully you isolated that k and you saw that if the k value is positive, it moved up. So that's a vertical shift, up k units. And when k was less than 0, it shifted down, vertical shift. So hopefully that is all you saw in the investigation. And this works with the square root function, but it works with all functions in general. We've got vertical shrinks and stretches, horizontal shifts right and left, vertical shifts right and left. I'm going to take a look at some negatives. So what about negative f of x when you have a negative out front? So again, if I'm looking at f of x equals the square root of x because I know what that function looks like, what happens when you have a negative out front? You probably saw this whenever you were looking at the a value in the last investigation. When you put a negative out front, you see the shape doesn't change, but we have a reflection about the x-axis. It's taking all of the y values and it's making all the y values the opposite sign. And then I want you to take a look at what happens if that negative is on the inside. So this time, instead of the negative being on the outside, I'm putting it on the inside. So if I were to look at f of x equals the square root of x, now I'm looking at f of negative x, which is the square root of negative x. What does that graph look like? Well, my parent function, still the same, square root of x, but now I'm going to have to extend this because when I look at that negative x function, it looks like this. So I can see this time I have a reflection, but it's in the opposite direction. The reflection is about the y-axis. And it's making the x values negative, which are, I guess, the opposite sign. So just to recap all of the transformations we've seen so far, vertical shifts up and down, we've got reflections about the x-axis. We notice that when you have a negative on the outside of my function. And we've got reflections about the y-axis, which happen when you have a negative on the inside of your function. There is a transformation that we're actually not going to discuss in this lesson. It is going to be on the investigation with fluid math that's going to come up in the next unit, but that's a horizontal shrink and stretch, and we are going to talk about that one probably last. All right, so what I want us to do now is I want us to look at this parent function. We're going to be looking at this parent function for the remainder of the lesson. We're just going to do a bunch of examples of transformations. This is a function that I made up, and it is a function because it's 1-to-1, and every x value has exactly one y value paired with it. I want to review domain, range, and then intervals of increasing and decreasing and constant before we transform. So for my domain, remember that's all the list of all the x values that get hit. So when I'm looking at this function, it looks like -4 is my lowest x value that gets hit. And then I pick up all of these x values until here, 6. So my domain is from -4 to 6. And I'm including the -4 and the 6. Now the range, let's go to the lowest y value that gets hit. That's -4 as well. And then I pick up y values all the way up until +6. So the domain and the range of this function are the same. That was not planned necessarily. They're the same, but hopefully you can see through this color coding how you're getting those values. And then I'm gonna erase that. Now let's talk about the intervals of increasing and decreasing and constant. First I want to go through and I just want to label what's happening. I'm going to go anywhere that's increasing, I'm going to highlight that in green. So I start out from left to right. If I were to walk on this line, I'm decreasing first. Then from this point to this point here, highlighted in green, I'm increasing. Then it's constant, and then it's increasing again. So if I were to say increasing intervals, I would start here at -2. Notice at -2, it's not increasing, it's turning there, so I'm not going to include it. And it's increasing from x is -2 to 1. If I'm splitting up the x values, I'm color coordinating. For these x values right here, the function's increasing. Then at 1, it stops increasing, and it starts again at 4, and it increases to 6. So I'm going to need a union 4 to 6. And since 6 is an endpoint, I get to include that since it's an endpoint on a closed interval. Now let's look at decreasing. So the function starts out decreasing. If I were to walk on this line right here, I'd be going down, I'm decreasing. And it looks like that's the only interval where the function is decreasing. So from -4 to -2, it's decreasing. Since -4 is an endpoint, I get to include that. But again, I'm not going to include -2 because the function is turning there. And now the last chunk. Here on this interval, the function is constant. It's not going up or down, not increasing or decreasing. It's just constant. And that is from 1 to 4. And I wouldn't include that 1 or that 4 because they're on the interior. So again, let me make sure I'm color coordinating this as I go so you can hopefully see how these intervals are created. It's important to outline that, the domain, those are the x values that get hit. The range is the y values that get hit. Now, when you're talking about the increasing and the decreasing and constant, these are intervals of x values that describe what the y values are doing, how they're behaving. So not a super technical definition there, but it's how I like to remember it. It's intervals of x values that describe what the y values are doing. So now what we're going to do is we're going to get into some examples. I believe I have 4 examples where I'm using the same f of x, and you can see that I've got the original parent function already on this graph for you. And that way we can go right into the transformations. In my experience, some people really like to work with a graph as they're doing transformation, and that's really all they need. But some people really like to go point for point, and so I'm going to illustrate both methods for you. I personally like more of a graphing method. That's kind of how my mind works. But a lot of my students really like to go point for point. So we're going to do both ways here. I want to warn you, I'm going to be really thorough going through these examples. So I think this lesson could be rather long if you're going through this with me, just because I'm going to do both methods each time. So it's just a warning that it could be a little longer than normal. Okay, so let's jump right into this first example. So here we have the graph of f of x given, and I'm asked to graph f of x plus 3 minus 1. So immediately I'm going to outline my transformations. The plus 3 I know is going to take the graph and it's going to move it to the left 3 units. Then I see that minus 1 here on the outside right here. And I know that's going to be moving my graph down 1 unit. Whenever you have only horizontal and vertical shifts, you can do them together. You can go point for point and do the transformations, and that's what I'm going to do. So I'm going to start at this first point. I'm going to move it left 3 units and down 1 unit. Then my next point, I'm going to go left 3, down 1. I'm going to connect them as I go. The next point, I'm going to go left 3, down 1. The next one, left 3 and down 1. And then the last one, left 3 and down 1. So this is my final graph right here. I'm just outlining it in the blue. So that would be the graph of f of x plus 3 minus 1. For those people who are point people, what you would do is you're looking at your parent function, and when you move left 3, think about what it does to the x values. It's subtracting 3 from all of the x values. So when you would go left 3, you're subtracting 3 from all of these x values. So my new points here, -5, -2, 1, and 3. And then when you go down 1, you're subtracting 1 from all of the y values. So here you're subtracting 1 from the y values. And you can do this in 2 steps, or you can do it in 1. So you have 1, -5, 0, 0, 5. And these points here that we've outlined here are the same points you have here, right in order. -7, 1, -5, -5, -2, 0, 1, 0, and 3, 5. Now last, what I want to do is I want to give the domain, range, and then the intervals of increasing and decreasing and constant for my new graph. So my domain now has changed. Notice the x values have changed because of this shift left 3. So my domain now looks like it starts at -7 and it ends now at 3. My range has also moved. It's all moved down 1. So I can see my lowest value for my y's is at -5 now, and my highest is at 5. Now when I'm doing my intervals of increasing and decreasing and constant, they've changed as well because those x values have changed. It looks like my intervals of increasing now are going, I can kind of outline them on my graph. I'm increasing from here to here and from here to here. It's still 2 intervals. So it's looking like it's from -5 to -2. And then again from 1 to 5. And I'm going to include this, actually that's not a 5, that's a 3. 1 to 3. There we go. To 3, increasing. It is decreasing on this first little piece from -7 to -5. From here to here, it's decreasing. And again, I get to include that -7 because it's an endpoint. And then it's constant here from -2 to 1. So there we go. There is that first example. Oh, let's look at the next one. So on the next one, I've got 3 transformations going on. You've got this negative out front, and it is a reflection about the x-axis. You've got this 2, it's a vertical stretch by a factor of 2. And then you have this -2 on the inside, and that's going to be a horizontal shift, and it looks like to the right 2 units. So when I'm game planning how I'm going to do transformations, where I have some A values and H values and maybe even some K values, if you just have horizontal and vertical shifts, you can do them at the same time. But any time that you've got a vertical stretch or reflection, I always advise that you do reflections first, shrinks and stretches next, and then you would do your shifts last. So first I'm going to do my reflection about the x-axis. So all of these points that are, I'm looking at the y values, that are positive will now be negative, and the points that are negative will now be positive. So I'm just reflecting all of these points about the x-axis. And then this is 6, 1, 2, 3, 4, 5, 6, counting. So there you can see in the blue here, I'm actually going to outline this. This would be the graph of negative f of x. Now the next I'm going to do the 2. So what I'm doing here is I am vertically stretching it by 2. It multiplies all of those y values by 2. So here my y value is negative 2. Negative 2 times 2 is negative 4. So that point moves here. Here my y value is 4, and 4 times 2 is 8. So I can see this vertical stretch starting. Here my y value is negative 1, and negative 1 times 2 is negative 2. Same thing here, same value. It's kind of nice having that little constant piece. And now here my y value is negative 6, and negative 6 times 2 is negative 12. So I'm going off my graph a little bit down there. I'm at negative 12. So in the yellow, this is the graph of negative 2 times f of x. And now my last step is to move to the right 2 units. So I'm taking all of these yellow points and I'm moving to the right 2 units. So this point goes right here. This point goes right here. And then this point goes right here. So this red is my final, negative 2 f of x minus 2. So I know the graph looks a little muddy, and so what I think I'm going to do is I think I'm going to go ahead and I'm going to erase, I think, everything except for the red. So you can pause the video if you want to see all of them together for a few minutes. I'm going to go ahead and start erasing so I can only see the final and the original parent function. Oh, I'm going to have to get my red back right there. I deleted some of it. Okay, let me get this back. There we go. So now you can just see the parent function and how all the transformations have affected it. So now I think we should go ahead and do our domain and range and our intervals of increasing, decreasing, and constant, and then we can go through and see how a person who is using the point method would work this and graph it. So for my domain, I've had several transformations, but really the only thing that has changed my domain really is that shift to the right 2 units. So I can see I'm now starting at negative 2, and then I'm not ending at 6 anymore. Now I'm going all the way to 8. Now the range has been greatly affected, the y values, because they were reflected and they were stretched by 2. So I can see my lowest value is down at negative 12, and my highest value is now at 8, and I'm hitting all of the values in between. And now my intervals of increasing and decreasing have also changed. So now, because of that reflection, I now have 2 intervals of decreasing and only 1 of increasing. I actually start out increasing now, and I increase from negative 2 to 0. Oops, and I don't want to include the 0. Let's make sure we have the right bracket. Then it decreases from 0 all the way to 3. And then it's constant from 3 to 6, and then it starts to decrease again from 6 until it ends at the x value of 8. All right, so now what I want to do is I want to talk about how, if I were going by the point method, how I would approach this problem. So first, because the negative and the 2 both affect the y values, I can do them both at the same time. So I can do the reflection, which is multiplying, I'm going to say multiply y's by a negative 1, and the vertical stretch, because you multiply the y values by the 2. I can do those both at the same time because I know that I've got an associative property that says I can multiply by negative 1 and then multiply by 2, or I can multiply by 2 and then by negative 1, or why not just multiply everything by a -2, since -1 times 2 is -2. So I'm multiplying everything by -2 on my y values. So that gives me a -8, no, a +8, my bad, 2. +4, -2, a -2, 1, a -8, 1, and a -12, 6. And so these points right here will match that yellow graph if you were to go back. That's both of these transformations. And then last, I need to move to the right 2. Oh my gosh, I just multiplied all of the x values and not the y values. That is such a bummer. Glad I caught that. How many of y'all were really confused there? Saying, why did you do that? I need to be doing the y values, not the x values. Silly goose. Gotta go back. We're doing y values. There we go. All right, so now this is going to match that yellow graph. I'll have -4, -4, -2, +8, 1, -2, 4, -2, and now 6, -12. That is going to match this yellow graph right here. I'll even put like a yellow box around it since I didn't color code it super well. All right. So now, with this horizontal shift to the right 2 units, right 2, that's where I'm going to be adding 2 to these x values. And that'll get me my final graph. So I'll end up with -2, -4, this point up here. Next point will be 0, 8. Here it is. Third point will be 3, -2, this point here. Next point is 6, -2, this point here. And then the last one is 8, -12. And there it is. All right, so we've got 2 more examples. This next one, I've got 2 transformations. The first one I see here, the negative on the inside, is a reflection, this time about the y-axis. So I'm going to do a reflection about the y-axis. And then this +4 that's not on the inside of the parentheses is going to be a vertical shift up 4 units. So 2 transformations. And again, when you have reflections, I would do those first. I would do any shrinks or stretches second, and then all my shifts last. So in the reflection about the y-axis, now I can see I'm changing the x values. So here the x value is a -4, and it would move here to an x value of +4. Here I have an x value of -2. It moves to +2. Here I have an x value of +1. It moves to -1. This one right here is 4, so it moves to -4. And here my x value is 6. It moves to -6. Notice the y values are not changing at all. It is just the x values that are changing point for point. And you can see how the black graph and the red graph look like if they were mirrored about the y-axis, they would land on each other. So that's what should happen when you have a reflection about the y-axis. I think we're going to go and do the point method with the graph method as well. So now let's do that reflection about the y-axis. See what that looks like. So here you can see now you're multiplying all the x values by a -1. They're just changing sign. So my new point values would be 4, 2, 2, -4, -1, 1, -4, 1, and -6, +6. So you can see these are all my points, but now they're kind of like going from right to left in order instead of left to right in order if I were to plot these. So then the next transformation up 4. So now you're just taking all of these new points and you're moving up 4 units. And that'll give you your final graph. This next one go up 4. So this is your final graph. So the red graph is f of negative x. The green graph is f of negative x plus a 4. And when I'm using the point method, point for point, if I go up 4, I'm just adding 4 to all of the y values. So I've got negative 4, 6. Nope, that's a positive 4, 6. 2, 0. Negative 1, 5. Negative 4, 5. And negative 6, 10. So you can see all of those points in the green up there for the final graph. For the final graph for the domain and the range, the domain is the x values. Looks like I'm going from negative 6, so I'm going left to right. Negative 6 is the smallest value, and 4 is the highest x value. For my range, looks like I'm going from 0 to 10 is what I should be going to, but that's not matching my graph, is it? Because I probably counted wrong. It looks like in this red right here, it should be 1, 2, 3, 4, 5. It should be at 6. Right there. So let's go ahead and fix that. So I counted when I switched my point. Let's go through so I can show you this. So this point right here, when it was reflected about the y-axis, it should have landed here. I accidentally had it down 1. I miscounted when I was looking at the y values. So now, when I move this point up 1, 2, 3, 4, there we go. So now that graph looks good. So that was kind of nice that I did not only the graph method, but I'm also doing the point method because I was able to catch that mistake. If I was just doing the graph method, I probably would have just moved on and not caught that. So my range is from 0 to 10, increasing, decreasing, and constant. Hopefully you guys are getting really comfortable going through these, so we'll do them all simultaneously from left to right. My function starts out decreasing, so when I'm at negative 6, my endpoint, it decreases until it gets to this next point, which is at negative 4. Then it's constant from negative 4 to negative 1. And negative 1, it starts decreasing again. And it decreases until an x value of 2. And then it increases for that final stretch from 2 until the end, which is at 4. So that is my third example. We've got one more to go. Okay, so on this last example, we've got a bunch of stuff going on. So you see the negative on the outside, that's going to be a reflection about the x-axis. You have this 1/2, which is going to be a vertical shrink or compression by a factor of 1/2. So we should see it vertically shrink. Now the inside is interesting because you see the negative on the inside attached to the x, so you know you're also going to have a vertical reflection about the y-axis along with that original reflection. So we're doing both reflections. And then you have this -3. Now this is tricky. This is a special case. Pay attention to this. This negative right here that's taking this reflection about the y-axis is also affecting this horizontal shift here. So at first sight, I'm thinking my graph is going to move to the right 3 units. But you've got to pull that negative out. That negative is affecting that horizontal shift, and I can't actually see it. So what I want to do is I want to rewrite this, and I want to factor out that negative so I can see what that true shift is. So if I pull that negative out, that reflection that's going to be about the y-axis, I would see that this becomes x plus a 3. Because if I would distribute the negative, I would go back to my original right here. So now I can see then I'm not going to the right 3. I'm actually going to the left 3 units. So again, I've got reflection about the x-axis, vertical shrink by a factor of 1/2, reflection about the y-axis, and then I'm moving to the left 3. So watch out for that. That's really the only special case that we've got going on right now, to see that how you got to pull that negative out so you can see the true horizontal movement. All right, so I'm going to do the reflection first. We're going to reflect the x-axis first. So when I reflect the x-axis, remember all my y values are becoming negative. If they're already negative, they're becoming positive. They're switching in sign. So 1, 2, 3, 4, 5, 6. I want to make sure I don't miscount that 6 again. All right, so left to right, that would be the graph of negative f of x. Now I want to do the 1/2. So that's multiplying all the y values by 1/2. So here, the y value is -2 times 1/2 is -1. Here, the y value is 4. 4 times 1/2 is 2. I should see it shrink vertically, which I do. Here, -1 times 1/2 is -1/2. Again, -1 times 1/2 is -1/2. And here, -6 times 1/2 is -3. So in the blue, I've got, this is -1/2 times f of x. All right, now it's time to do the reflection about the y-axis. So all of these values, the x values, are going to switch. So this is a y value of, or x value of -4. So now it's going to land here, a +4. Here is my x value of -2, goes to +2. Here is an x value of -1, or +1, so it goes to -1. Here's x value of 4, goes to -4. And here is an x value of 6. It's going to go to -6. All right, so that right here is -1/2 f of -x. All right, one more. I need to move this graph to the left 3 units. It is starting to look like a muddled mess. So I've got 1, 2, 3, just moving everything left. 1, 2, 3. 1, 2, this point moves right onto that point. Here, 1, 2, 3. And the last one, 1, 2, 3. So here in the yellow is my final graph. Final one, and if you want to see all of those, then go ahead and pause the video. I'm going to go ahead and erase everything except for my yellow so I can see more clearly that final transformed graph. Try my best to keep all the yellow intact. Okay, so now make this yellow perfect. Got those points. There is my final graph there. So if you were a point person, I probably would have done this in 3 steps. I would have done the negative and the 1/2 together. So that's multiplying the y values by -1/2. So multiply y by -1/2 first. That would have taken care of the stretch and the reflection. So when I multiply all those y's by -1/2, I'd have -4, -1, -2, +2, 1, -1/2, 4, -1/2, and 6, -3. So that would have been my first step. Then when I did the reflection about the y-axis. That would have changed all my signs of my x values. So that's 4, -1, 2, 2, -1, -1/2, -4, -1/2, and -6, -3. And then that last step, when I moved everything to the left 3, I'm going to get rid of my color coding right here so I have more space. I would have been subtracting 3 from my x values. So when I do this, I should see the same points I have graphed up here. So I've got 1, -1, -1, 2, -4, -1/2, -7, -1/2, and -9, -3. So it looks pretty good. 1, -1, -1. I have -1, 4, not -1, 2. -4/2, -7/2, and -9, -3. Those look good. So let's take a look. Okay, so going back to, I'm trying to retrace my steps, but I erased it, which is kind of a bummer. I know that I took this point right here and we reflected it to +4, then it moved down and I can still kind of see that remnants right there. Then it was reflected and it was here, and then when it moved left 3 it should have landed right here. So I'm not sure exactly how that got lost, but this point should be here. So maybe the lesson here is that I should, even though I prefer the graph method, maybe I should be checking behind myself with points every single time to make sure I'm counting correctly. So there are all my points in this final yellow graph, and now it's all looking good. So now my new domain is going from -9 to +1. My new range should be smaller because of that vertical shrink. So it looks like I'm going from -3 and I'm going up to 2. Intervals of increasing, decreasing, and constant. I start out increasing. It's from -9 to -7. Then it's constant from -7 to -4. And then it increases again, starting at -4, and it increases until -1. And then it's decreasing for that last stretch from -1 to +1. And there's my end point. So now that you've gone through all of these examples, we've hit all the highlights, and you should be set to do the problem set on your own. Again, we did not do horizontal stretches and compressions on any of this. You're going to be looking at that on the next investigation, and that'll wrap up all the transformations.